Good evening, everybody. This is Enora Lesker, Senior Naval Architect at Order and one of the newest members of the Aberdeen Maritime Branch Committee. Tonight I will be hosting the presentation for Alpha Laval. So the guest speaker is Tristan Matthew. So he has been working for Alpha Laval since 2016. Where he started in service sales before then moving into managing of ballast water and capital sales business. He's now responsible for all the marine aspect of Alpha Laval throughout UK and Ireland. Prior to that, he worked in the marine industry for all of his working life. Whether it was for manufacturing, leisure, or oil and gas industry. So tonight he is going to be talking about a topic on sustainability in shipping, and I will let him discuss further on this topic.
Thank you very much, Enora. Thank you. And good evening, good afternoon, good morning, everyone, wherever you are listening to this. Thank you very much. So as Enora said, my name is Tristan Matthews. So I'm the Marine Divisional Manager for Alpha Laval, UK and Ireland. I've worked in the marine industry for almost 27 years now across a variety of roles. So very, very grateful to have the chance to come and talk to you today about sustainable shipping and decarbonisation. It's something that I'm incredibly passionate about, and really appreciate the opportunity to walk through some of this. So just to give an idea of our agenda for today, so rather than focus on what we already know, I'm going to discuss some of the wider global messages and how some of these can influence our decision making. I'm going to discuss the work that's already being done to support the industry through these changes, and I'm going to try to bring some focus to some potential solutions that can help meet the needs for this ship of the future. So as we transition through this decarbonisation pathway. So why is a company that is arguably better known for boilers, separators and heat exchangers talking to you about sustainability and decarbonisation? Well, at Alpha Laval, our purpose has sustainability at its core. So before we get into what it means for the marine industry specifically, I'd ask you just allow me a few minutes so we can look at the wider picture and take some context on this. So you'll see later on how the relevance of the global message has an impact in the work we're doing for the shipping industry. Business has to grow, global shipping trade will likely continue to increase. The forecasts all give us that, and we've seen the tonnage increase year on year. So one of our principles at Alpha Laval is to provide innovative ways to enable this growth whilst respecting the planet. So we regard sustainability both as a necessity and as a business opportunity. Our technologies promote a more responsible use of natural resources, and we constantly drive progress to help reduce the environmental impact of most of our environmental processes, both on land and at sea. Our business is split into 3 divisions to provide focus and specialist knowledge. We contribute to improved energy efficiency and heat recovery, better water treatment and reduced emissions. But let's look briefly into one land-based area that actually has quite some synergies with marine, and that's an area of clean energy. So this image here is not a marine graph. You could be forgiven for thinking it is, but this shows a global transition towards clean energy. So the marine industry's transition towards decarbonisation forms a part of this. The challenge of decarbonisation is twofold. We must simultaneously support rapidly growing energy demands whilst reducing emissions, and this is if we're to meet the goals of the Paris Climate Agreement. So as you can see from this chart, from IEA, the International Energy Agency, a combination of technologies and new fuels are needed to reverse our current course and put us into the sustainable development pathway for meeting the Paris objectives. So in terms of clean energy, the green section illustrates the important role played by renewables, And then the orange portion of the chart below that shows that new cleaner fuels and carbon capture will be equally important. And you can start to see here the pattern that emerges. These are very much topics and conversations and words that we hear in our industry today. So again, looking at the wider picture, Alpha Laval supports many industries around the world with clean energy transition. The knowledge and solutions are not always unique to marine, so we must all look for opportunities to create economies of scale. However, this also means that there is a demand for similar technology outside of our industry, and this is part of the unknown that faces us in marine. We have already seen, for example, in the global semiconductor shortage, how demand from much larger industries has placed pressure on our supply chains, and we need to have our eyes open to similar opportunity and demand situations when talking about the decarbonisation pathways. So with that in mind, let's take a closer look at our industry, the marine industry. We'll look first at some of the legislation, the routes to compliance, and the drivers. So the drivers there, these external changes drive demand in our industry. I'm not going to spend a lot of time today talking about the various pieces of legislation that affect us. For one, they are well documented elsewhere, and for another, arguably there isn't much we can do about it at this stage. The need to comply exists, and this we cannot control. What is important is to look for the opportunity and find ways to use this demand. As you can see here, growing energy needs, stricter environmental legislations, higher standards of living, globalization, and impact of climate change and water scarcity. These are all drivers. These are all parts of the industry that are pushing towards a cleaner, greener society. So just to very quickly look at the inflection points and what it does mean, this is the one legislation slide we'll go through today. But this information is probably well known to most of you, so I'll only recap it. But here you can see the IMO 2030 target and then the 2050 target. The targets being 40% reduction in CO2 for transport work for 2030 and 70% reduction by 2050. The short-term measures the IMO have implemented need to fall in place by 2023, where the focus is on improving energy efficiency, and we're all very much aware of that. The mid-term measures are yet to be discussed, but these will be the next steps where the IMO focus will be on market-based instruments to drive changes and uptake. It could be in the form of some kind of CO2 tax, CO2 trading or similar. But the only thing we do know at this stage is these are all regulations that need to fall in place before 2030. So then after 2030, in what we're calling the long-term measures, the IMO will engage in developing these. And again, we don't know what these look like yet. What we do know is that regulations regarding greenhouse gas in general is a major inflection point, and it will force shipping to deploy alternative fuels and increase energy efficiency to an extent we've not seen before. We're not sure what this looks like yet or how this is going to happen. So these discussions and decisions are still yet to be made. And it will be interesting to assess to which extent the ship owner is willing to go with energy saving technologies or decarbonising technologies. And these are all very interesting topics, or they're very challenging topics, depending on how you view them. But again, I said I wanted to look at something different. And yes, there is a requirement to comply with the legislation. That is unavoidable. It is worth remembering, though, that there are commercial drivers that create opportunity within our industry. So with public commitment from large companies to move their cargo using zero carbon shipping, there is a commercial driver for early adoption and a business case that creates opportunity beyond the need for compliance. And that can be overlooked, and it can be misplaced as well, that this is not always about the need to comply and about winning that certificate. There is a business case here as well that supports it. So let's take a look into our test and training centre, and we'll show you some of the things that are going on to help meet the needs. So Alpha Laval is a member of several coalitions and partnerships, such as the Mercer McKinney-Moller Centre for Zero Carbon Shipping, the Getting to Zero Emission Coalition, and the SOFC4 Maritime Partnership, that we are working together with to help find solutions and develop and commercialize products, establish standards and influence policy. And we don't do this alone, we do this together. The Test and Training Centre in Aalborg is used to test many of the future solutions, and as you can read there, is the world's most advanced test centre for environmental and combustion technology for the marine industry. As our CEO said once, we're in a whole different way of existing now with decarbonisation. The pace of change is so high, we can't just do what we've done before. That is, we have an idea, we go away in our labs, we work on it, and 5 years later we come out and release something. So the need for partnerships and the need for working together has never been greater if we're going to find a way to meet these goals together. So this is a bird's eye view of the Test and Training Centre in Aalborg, Denmark. We're already preparing for future fuels. We have tanks and permits in place to test HFO, MDO and gas. In 2021, we added methanol and biofuel capability. And then in 22 or 23, we will add ammonia as well. And we're also looking at hydrogen. And as you can see, it's a busy slide, so I apologize. But as you can see from the image there, there's a lot of equipment that gets tested there. So we can replicate the running of a ship's engine, and we can replicate the load on equipment, and we can test and try various things. We also have other new products in development in that site. So in terms of future fuels and what that looks like, we'll take a little drill down now into the future fuels scenario, the market situation, and then we'll have a bit of a discussion around those points. So again, another busy slide, and apologies, but this shows a couple of interesting things to me, if the potential at least is to be believed. The first one there, under the blue arrow, it shows that in the past, and at least up to mid-decade, we can say that there is only really one significant type of fuel, and that is oil-based. But if we look forward now, we can see that from the mid-2030s and beyond, we have up to 8 different potential fuel types in use. And that's a lot of change in 10 years. So, we can see on the left there what the existing fuels are, the fuels that are in front of us, and then the next generation fuels such as hydrogen, ammonia, methanol. So let's have a look at the current situation with these future fuels. What I would like to say at this point is that this is the viewpoint of Alpha Laval. We are constantly monitoring this, and as always, it is subject to change. The market is moving very fast in these areas. So alternative fuels exist in the near and long term. One thing that they all have in common is they each have some advantages and disadvantages if we compare them to a reference fuel, say MGO. You can see from the colors here, green is low uptake complexity and red is a high uptake complexity, yellow in the middle, that some fuels are relatively mature in terms of their readiness, whilst other require further development, infrastructure or technical developments before they can be considered viable. And again, each fuel is at a different stage depending on what element of the pathway you're looking at, whether that be storage and handling, technological maturity, production, or emissions. So one of the common threads through this is that most alternative fuels have a lower energy density and a greater cost per megawatt hour than their oil-derived equivalents. This means that decisions will need to be made in terms of vessel operation and what equipment goes on the vessels to provide the right balance of efficiency and operational performance. It may mean taking an innovative approach to the type and selection of equipment on board to suit different operating modes. For example, port, coastal, dynamic positioning, short, long-range operation, etc., with a number of different but complementing products depending on the need of the vessel and the need of that particular ship. And let's take a look at some of the examples there now. So in terms of marine solutions, what solutions exist and what does the ship of the future look like? To meet the demands of the short and longer term will require a very different way of thinking, and not one solution will work for all vessels. There are already solutions that support LNG, either as cargo or fuel, and this trend will likely grow if it becomes commercially viable as a fuel. Waste heat recovery and cogeneration is an area that most existing vessels could develop to greater effect, improving thermal efficiency with newly developed heat exchangers, lowering emissions with products such as fuel cool, which helps reduce methane slip. Today, we need to fuel a new phase in decarbonisation. So methanol is likely, to be the next step in the marine industry's journey towards a zero carbon future, as it promises to cut CO2 output by up to 95%, whilst also reducing or eliminating other vessel emissions. If produced from renewable green sources, it can bring us to a level of carbon neutrality even. However, methanol will demand new technologies and a different way of looking at the energy balance on board. And that's the same for many of the new fuels. Looking at 2030 and beyond, to really shift the needle here as we move towards that 70% reduction, it's going to take thinking about power generation, operation, and propulsion differently. Solutions such as wind-assisted propulsion, air lubrication, alternative power generation using fuel cells, and weather routing can offer greater savings and do not have the restrictions that come with engine power limitation. It is worth mentioning that safety is paramount with new fuels, and this will require additional equipment and training for both crew and service personnel. And this is an area we're not touching on today, but it's a really important area, in one that pick your partner is probably a good metaphor for use there, that make sure the company that you're in working in conjunction with when you move down this pathway really understands the safety aspects beyond with the equipment and how to service and maintain that, and indeed how to train your crew on using it. So as we look at and even further down into some individual solutions, and one possibility to help reduce CII, maximize the energy value of future fuels, is, for example, to use an existing boiler as a safety system with a future fuel source. This could be done with methanol, ammonia, hydrogen, but this is a concept. This illustration there shows a concept for a methanol fueled vessel using the boiler as a burn-off system. So this could be suitable for either cargo carrying or a methanol fueled vessel. And we've actually got an approval in principle from ABS for this system to start developing this and work with a customer to supply one of these. So a very nice, unique solution that eliminates the need for a burn-off unit or a gas combustion unit, particularly with the lower energy density on the future fuels. This is something that is a nice and, again, innovative way of looking at how to maximize that fuel. Some other developments, as we previously mentioned, cogeneration is an area that really can be explored further. That's here and now as well. So products such as ePower Pack, we can use excess waste heat that then can be converted for electricity for use back on board. So significant, improving the efficiency of an internal combustion engine even further, offering fuel savings and carbon dioxide reduction, so reducing that CII further. And then there's a lot of development work being done with fuel cells. So we already have a high temperature proton exchange membrane fuel cell in our test and training centre, and we're evaluating solid oxide fuel cells, and we're looking to get those in place as well for testing in future. We're going to scale up somewhere in the region of 200 kilowatt cells, and then we're looking at pilot projects around the 1 megawatt load on solid oxide already. So fuel cells offer greater or at least offer potential for much greater efficiencies than with internal combustion engine in conjunction with cogeneration. And you can see efficiencies up to 70 or 80% thermal efficiency with something like a high temperature solid oxide fuel cell and cogeneration on the using the exhaust heat set. So it's a very viable option for the future. Then again, as we talk about, a decarbonisation toolbox at Alpha Laval, and I think this is really the message here, is that we're going to have many new and innovative ways, and we're going to have to, potentially have to require multiple options on the same vessel in order to meet the needs for the future. But, the saying, what is old is new again, I suppose, or is it something from folklore? The real innovation that we're going to need to meet the 2050 goals means thinking outside the box, and areas like wind-assisted propulsion has already seen some notable mentions in the press. So that will likely feature on certain types of vessels in future. Weather intelligence is an area that can be a great addition in this decarbonisation toolbox to help safety and provide analytics on performance, reduce risk, improve safety, and help the customers or the vessel operators or the vessel owners make more sustainable choices in the future. It can really help them analyse the impact of the equipment or the decisions, even down to basic, when do we go, when do we stay, where do we point the vessel. Then air lubrication, that's already quite well known again, is an absolutely excellent choice for the right vessel type. So, and all of these options, they offer, needle shifting potential for energy savings. So not just sort of small incremental gains, but some significant gains there. And, we're also monitoring developments in areas such as carbon capture and storage, or carbon capture utilization and storage, energy storage for electrical energy. As with most companies of our type and size, we acknowledge that other solutions exist, and we will add more to our portfolio over time. So it's going to be a very interesting development as time goes on, and the reality that it's here and now. We have to start making decisions now for the future. We're not going to be in the right place for the end of the decade if we don't make decisions in the short term. Even if the equipment doesn't exist yet, we need to, but it's coming, and we know there's some development on that. We need to start making forward-thinking decisions on that. So that's a really important message there. And then to summarize then what we have here and what we've talked about today is that sustainability is at the heart of everything we do. Meeting the Paris Climate Agreement goals will take more than the stated policies, and that trickles down through us, through the IMO, through the US Coast Guard, through the EPA, and through the EU. And we know that we're going to have to make bigger changes than is in the stated policies if we're going to reach those end goals. But there is a silver lining. There is positive opportunity there. Globalization and commercial drivers exist outside of the need for compliance. So that's a really good message to take away from today. And that companies like Alpha Laval, us with our test and training center, and other companies like us are already set up and are already testing with alternative fuels and solutions, and more are coming. I think this is the one that cannot be understated, is that fuel choice for shipping is entering a paradigm shift over the coming years. This isn't so much of a market trend as a whole new way, and I think it's really important that we understand that as an industry and really get our heads around that as soon as we can. I think getting to grips with what is the right fuel type for my vessel in the area that I operate is a critical part of evaluating this next phase. The ship of the future, as we're calling it, will require a very different range of equipment and mindset, both in terms of equipment selection, the type and amount of equipment on board, whether that be things like internal combustion engines, shaft generators, hybrid drives, batteries, fuel cells, exhaust gas recovery systems, SOx reduction, particulate matter reduction, air lubrication, weather routing. These are all potential tools in the toolbox to use that the ship of the future is going to need. And I don't think there's, or I firmly believe that there's no one size fits all with this. And it's going to be a very unique approach. As we saw a few slides back, the 8 different potential fuels, everything from nuclear to electricity to oil-based to gas to green ammonia and green hydrogen, and and those are all there. Those are all going to exist in the future in one form or another. And then finally, we are in this together. And that's the message that we have, and hopefully in by presenting this to you today, is that we are in this together. This is not a battle or a challenge that any individual company or individual product can face alone and can solve alone. So it's very much about active dialogue, active participation, working on the solutions. We at Alpha Laval are trying to do our bit towards this, and we're very much working with every part of the marine industry, from the supply chain through to the class societies, and we sit on various different councils having influence with the legislators as well, to try and make sure that informed and correct decisions are made. And we want to have opportunity to talk to the rest of the industry in order to do that. So that's our message, and that's it from me for today. Thank you, and I'd like to hand back to Enora and see if there are any questions, please.
So yes, Tristan, we have received a couple of questions.
Good, thank you.
So the first one was, is ship design itself going to be taken into account whilst trying to reach the decarbonization process? So the question was quite short, but I assume it was meant to be quite specific to the design, of either or the systems.
Absolutely. Ship design is not my area of expertise. I think there are a lot of areas which we haven't touched on, which also come into that. Propeller design, ship design. Yes, those are important factors. I mean, if you look at, for example, the wind-assisted propulsion, that's going to take a very different design of ship to maximize that impact. And certain vessel shapes don't lend themselves to technologies such as air lubrication. So I think, absolutely, ship design is a fundamental part of that. Where I remain healthily skeptical with a good balance of optimism is around the way EEXI is currently calculated, and obviously the impact then of CII favours engine power more than it does ship design at the moment. So I hope we'll see, as we move towards 2026, some real advantages and some changes in that area, and that the companies that are strong in design and improving those, really making those benefits, are working hard with their legislators in those fields to have that impact, because that's an area that, it's going to be the sum of the parts. That's going to be the piece of the solution to this puzzle. So long answer to a short question, but great one. Thank you.
We have received a couple more questions, but I think that they're all related to the design, and I think you have already answered them.
We didn't touch at all on ship design today, but as I say, that's not our area of expertise, and not an area that I can really cover. But I think we'll see some very innovative and interesting things in that area, both underwater and above the water.
Yes, exactly. One of the questions was if naval architects were getting design briefs on how to design ships for sustainable shipping and decarbonization. Which is, as you said, it's not exactly what we are discussing today.
No, but I suppose I can give some context on that. And that, for example, with the Maersk McKinnon Muller partnership that we're in, there are a number of ship design companies, class societies that are active on that. So we get input into the future products, future solutions with all the areas of the market in balance. And as a solution provider, we also talk with ship design companies on a regular basis to make sure that they're aware of what products are available, so they can design with that in mind. And that really is a big part of the challenge of the future, is that someone that's building a ship now to meet the needs of 2050 is going to have to build a ship they know that the equipment's going to have to be replaced in, or some of the equipment's going to have to be replaced or upgraded at some point in the future, simply because the equipment is either not commercially viable or not technologically available yet. And that's a really interesting challenge to overcome, and that's where again, innovative ship design, working with and closer with partnership with equipment providers can make some really smart choices and can produce some good things, I think.
Thank you very much, Tristan, for the excellent presentation. I wanted to pick up on a point you made about the pace of change. I thought that was a very interesting comment, and how do you manage and address that pace, especially when as you just mentioned, there's uncertainty in the future.
Absolutely. I thought long and hard about what to introduce into that today, and it, because it is a very difficult and interesting one, and the reality there is that it's working together again. That's the only way we're going to do this as an industry, and that means that it's going to take some brave decisions on behalf of the ship owners, ship managers and ship charterers to be early adopters and be prepared to be early adopters, and that's not for everyone, and we get that, and not everyone's in a commercial position to do that. It's also going to take very brave decisions and very brave choices on the part of the solution equipment manufacturers and solution providers to be ready for these changes and to step into an area that they may be less comfortable and is not in their comfort zone. And that's something that we've done as Alpha Laval. So we've actively sought out partnerships, because we realized that if we went and tried to do things traditionally, we wouldn't get there as fast as the industry needs us to. So I think, it's a big shift for us as Alpha Laval. Historically, we've done all our R&D work ourselves. We've come up with the ideas, we've gone into our labs, we've developed them, and we've released products and then incrementally improved those products based on customer feedback over years. We've also made growth through acquisitions over the years. I don't think the growth through acquisitions will change, and that's a part of any large company's portfolio. But I think what is unique is that developing products now is very much done in partnership, and not in place of doing our own work.
Thank you.
Sorry, Chris, go on.
There was another question, basically along the similar lines. Do you see opportunities for collaboration across different industries to find optimal solutions?
Absolutely. That's why I spent some time talking about the wider industry, the wider problems, because I think there's tons of development work going on in other industries, such as if you look at the energy storage work and development that's being done in the energy sector now, that's looking away from, for example, batteries, and looking at long duration energy storage and alternative means of storing electrical energy. I think those have some real potential for marine. It's not there yet. It hasn't even been commercialized in the onshore world, so it's not ready for a marine environment, but it could be. I think another area is something like carbon capture and storage. Now, we're actively following that. We're looking at it. There are a number of ways to look at that. I speak to a lot of people at the moment who believe or may have a belief that that's something of a silver bullet to solve at least some of the problems in the short term. But the reality with carbon capture and storage is it's not easy. It's very expensive, it's very big. And so to commercialize that, to bring that to a scalability for use on board a ship, is going to take more thinking than one company can do. And so that's going to be an interesting one. And there are plenty of other opportunities such as that. Power distribution, that's going to bring a whole new challenge on board vessels. When you're talking about having multiple sources of power that are active at multiple different times, including things like shore power, cogeneration, fuel cells, shaft generators, conventional diesel electrics, how do we manage and distribute that on board? And especially if you look at something like a DP vessel, which then has very unique power demands, and depending on what it's doing, and how do we optimize the vessel for that 80% of time it's not on DP, whilst having enough reserve there for peak shaving and DP operations. So those are really interesting challenges that there probably aren't the solutions for all of that yet. We can get some of the way there right now, but not all of the way.
Okay, Tristan, we have received one more question, which basically is referring to one of your slides. It says that you have mentioned that the peak of fuel oil consumption would be around 2025. And then the question is asking which technology do you think will be the most relevant one after 2025 to really have an impact, on the reduction of that consumption.
Yeah, well, I think the thing to say about that slide was that it was a potential, so it was a hypothesis about a project, so it was a projection that was done. So it's not stating that that's going to happen, it's just saying that's one of the most likely scenarios that we will see that. But anything could impact that. We have a very interesting situation in the world right now that's really impacting fuel and gas and oil, and that could change that at any point in time. I think, as you saw there, that what you're going to see is old fuels, new fuels, and transition fuels. I think if you put them into those three buckets and look at it that way, the oil-based fuels will be on the decline from mid-decade. That's probably fair to say. Then there'll be some transition fuels in the interim, things like energy, gas, LPG, LNG, and then some other transition fuels that are pretty much ready. They just need some industrialization, like methanol is there. And then as we move on further down the line, you're looking then at things like green ammonia, green methanol, green hydrogen, and other, potentially nuclear. And we will see probably electricity develop in terms of a viable fuel, or at least be very viable for things like short duration voyages, coastal operations, etc. So there's going to be a transition for sure. Yeah, not one answer to that slide, and I think if anyone has the answer, give me a call with the lottery numbers as well, because I could do with them.
I think so.
I mean, with everything with most of the situation we've talked about today, it's all subject to being stalled by geopolitical issues and demand, and with the price difference per megawatt hour of alternative fuels, it will take something more than choice to drive that. And I think we'll see that around the turn of the mid part of the decade in 2026, when the next phase comes in with the IMO legislation. If, for example, some of the calling right now is for there'd be a tax on oil-based fuels, and if that happens, for example, that could completely change things overnight. So then other fuels which are now at the moment not commercially viable suddenly become incredibly viable. And we saw that back in 2019 with scrubbers. It was a good example where the fuel delta between low sulfur fuel and conventional fuel was so great that there was a very good business case on a lot of ships for scrubbers. But then COVID came and the oil market, suddenly wasn't there, and that industry, the business case wasn't there anymore. So it's about being ready to take advantage of the opportunities as they come up, really.
Okay, I think that that is all the questions we have received so far. Maybe we'll leave it another couple of minutes to see if anyone else wants to comment on your
no problem
last comment.
One of the things I can say as well is and one of the questions we get is why not now, when we talk about developing other fuels, and I think that's a very interesting and good question. The reality is, because we can't do it all at once. I mean, some of these alternative fuels, whilst we can build equipment for them, there isn't, for example, the legislation in place to understand how to operate those safely yet on the ships. So that needs to take place in conjunction with this. And we can't, everything has to be put into place as well in our facilities, and it's impossible to just test everything side by side simultaneously. So we've put the best plan that we can forward, as has every company, and following what we believe will be the most likely fuel scenario and the most likely development scenario. And we'll adapt as that changes and as that adapts. But it certainly, if we could do more, we would. But everything has to be planned, unfortunately, and there's only so much capacity for R&D.
Okay, I think that is all the questions we have had for today's webinar. So
Good.
I think we can probably one more. Right. I think we just received a question which is probably quite close to one of the comments you made on the fact that we needed to have various people involved, you know, whether it was governments or industries or but the question specifically asked, is the infrastructure policies of governments, yards, etc., getting ready for the massive changes?
I'm sorry, could you repeat the question, Enora?
So the question asked, is the infrastructure policies of governments, yards, and other actors getting ready for the massive changes that, you know, decarbonization does require?
That's a really good question, and that very much varies. So obviously, I mean, the IMO, you know, we know what the IMO is. That is the member states that make it up. So I think the governments are ready in that they've ratified to the Paris Accord, or most of the ones have, and you know, the IMO is quite, you know, steadfast in its position. So we're there with that. The infrastructure is getting there. And that very much varies by area, by region. And then you talk about adoption is probably the last part of that, and that varies wildly. There's a massive swing in, again, some companies which can, want, and are able to early adopt and are making those steps, and there are others which are very much wait and see. There are also some niche areas, some parts of the market where they will want and need to wait for things to be clarified and other pieces of legislation to come out. So I talk about areas like the drill ship market, which is always quite unique in the way it operates, or FPSOs, you know, and those types of vessels which are quite unique, and so they may have specific needs. And there, I think, you know, we'll probably see a wait and see approach. But the yards, we're not seeing any issue with yards that will want to build vessels for the future. And I think, you know, if you look at the shipbuilding data now, some 40% of vessels contracted now are at least ready for alternative fuels. So there's not really a problem in yard infrastructure. There's not really a problem in at least, you know, ship design, as we call it at the moment, with conventional vessels and getting them ready. You know, that's very much up to the customer's choice at the moment. There's not a lot of commercial issues there, I would say, but mainly around who wants to make a decision. But it does vary by region, and yeah, it's hard to make a blanket statement on a global platform like that, and so that there's going to be loads of errors in what I've said and loads of examples where it doesn't apply, and I accept that. I'm trying to give some general and broad statements for
that. Okay, so I think it says, you know, your last comment is probably a nice way to conclude. As you mentioned that obviously there is a lot to do when it comes to decarbonization, and there's a lot of different people involved for it to happen. Everything is moving forward, and then obviously there are things to take into account. It's not going to change overnight, but there are things happening, and the industry is moving with it, basically.
Absolutely.
Okay.
Yeah. We're ready for you know, to discuss the solutions and challenges with all of the industry, you know, for across the length and breadth of it. And thank you again for the time today. Thank you again to the audience for joining us, and I appreciate the opportunity.
Perfect. Well, thank you, Tristan, for your presentation. It was very interesting, and I'm sure all of the audience will agree with that.
Great. Thank you.
Okay. Thank you. Bye.